Okay, so in today's session, in today's class, we'll talk about the decoder. First, we'll see what is decoder, okay, and why it is called as decoder. You know something like coding, encoding, encoding and decoding. Sometimes you have seen in the reasoning also, decoding and encoding part. So it is somehow similar to that. We need to decode any number with the help of binary combination, with a given binary combination. So, first of all, I would like to tell you, decoder is a combinational circuit which is used to convert an input line to the maximum of 2 is to power n output line. So, n input line. Similarly, if we talk about 2 input line, we will get 4 output lines. Correct? So, here you can see in this diagram, this is called as 2 is to 4 decoder. A and B are our 2 inputs. D0, D1, D2, D3 are our outputs. Correct? So in decoder, input side we have n inputs, output side 2 is to power n output. So in 2 is to 4 decoder, n inputs, that is the 2 inputs, output are 4. Concept is that for any given one combination, only one output will be high at a time. Remember this statement. In the decoder, only one output will be high at a time. Like that, if inputs A and B both are 0, D0 will be 1, and D1, D2, D3 all are 0. If inputs are 0, 1, D1 will be high. If inputs are 1, 0, D2 will be high. If inputs are 1, 1, D3 will be high. Other 3 outputs will be 0. So, what is the truth table here? You can see inputs and outputs. A, B, D0, D1, D2, D3 are 4 outputs. So we have 2 inputs, 4 outputs. Okay. Inputs are 0, 0, D0 is 1, D1, D2, D3 are 0. Inputs are 0, 1, D0 is 0, D1 is 1, D2, D3 are 0, 0. Inputs are 1, 0, D2 is 0, D2 is 1, D0, D1 and D3 are 0. Inputs are 1, 1, D3 is 1, inputs are 0. That's why here n inputs, you have 2 is to power n outputs. Because at a time only one output will be high. Okay. So here I will write something for you decoder, regarding the decoder. This is 2 is to 4 decoder. Inputs are 2, A and B. Outputs are D0, D1, D2 and D3. Okay. So before discussing about this, I would like to tell you one more thing. Procedure to design any combination logic circuit. So here you can see what is the procedure to design any combination logic circuit. Decoder is a combinational circuit. We need to design the circuit diagram until and unless last point is the design logic circuit. So we have to design logic circuit diagram for 2 is to 4 decoder. So what is the procedure for that? For designing any logical circuit, we require logical expression. How can we get the logical expression? We require truth table. So we'll construct the truth table. How can you construct the truth table? Based on the input-output relation. Correct? So in first step, you will have to identify number of inputs and number of outputs. In decoder, we have 2 inputs and 4 outputs. So first step, we identify number of input and output. Based on the relation, we construct the truth table. What is the relation? Based on the relation, we construct the truth table. So we'll design the truth table, and we know for any one combination, output will be high. So unique representation for each combination. So we can construct the truth table, and based on that, we'll write the logical expression that should be minimized 1, and according to that, we'll draw the logic circuit diagram. So first is the input-output relation. This is the input-output relation that we know, and we can construct the truth table. Follow the steps. We'll construct the truth table where inputs are A and B, outputs are D0, D1, D2 and D3. Okay. So inputs are A is 0, B is 0, D0 will be 1, D1, D2, D3 are 0. For 0, 1, D0 is 1, D0 is 0, D1 is 1, D2, D3 are 0. For 1, 0, D0 is 0, D1 is 0, D2 is 1, D3 is 0. Similarly, for 1, 1, you tell me which output will be high?
D3.
D3.
So here, this is the combination. This is a truth table. You can see this is a truth table we got. And here, this is nothing but if we have one combination of this, you can decode which output should be enabled. We are decoding which output should be high for this given input combination. If we give here 1, 0, you can understand only D2 is high. What if a decoder will not work if we assign like this? If we assign like this, decoder will not work if we assign 1, 0 combination to D1 and D2. If inputs are 1, 0, you will not be able to decode which output should be high, either D1 or D2. That's why for each combination, unique representation should be there for decoding. With the help of combination of the binary number, you can decode the output. And it is only possible when for each combination, unique output is high. Is this concept clear? Now from here, you can get D0 is equal to A bar B bar. Okay, you tell me expression for D1.
A bar B.
A bar B.
Expression for D2.
A B bar.
Expression for D3.
A B.
A B. So these are the expression that we got, and this is not possible. So I'm just I will remove this thing so you will not confuse when you see this presentation. Okay. Now, with the help of first we find out the input output relation, design the truth table, find the logical expression. Now you can design the logic diagram that is shown in this. That is shown in this presentation here. Okay. D0 is A bar B bar, D1 is A bar B, D2 is A bar, D3 is AB. So here you can see that AB are inputs and 4 outputs are here, D0, D1, D2, D3. This is a logic diagram for 2:4 decoder. Okay. So now here 2 inputs are decoded into 4 outputs. 2 inputs are decoded into 4 outputs, each output representing one of minterm of 2 input variables. So each output is representing one of the minterms. Okay, each output is representing one of the minterms. Do you remember? Do you know what is minterm? Do you know what is minterm? Recall that in first module we discussed about the minterm. Okay, either if you don't remember, even though you try to say something, so you definitely reach to the conclusion. What is minterm? Yes, we'll recall.
Product terms.
Product term. Sum of product. Sum of product is not a term. Sum of product is a one expression. Sum of product is one expression like this. If I write one function AB like A bar B plus AB bar, this is the sum of product. This is a function. This is not a minterm. Something else? If you say something, you will clear your doubt. Now you got the idea what is sum of product, how sum of product differ from the minterms. So you say something, I will correct you.
Product of variable.
Product term. Product term is somehow correct but not exactly correct. Can anyone correct it perfectly? How product term is differ from the minterm? Yes, come forward. Unmute yourself and say something.
Sir, A dash B plus AB dash is sum of minterms, and these terms A dash B and AB dash are minterms.
Okay, these are the minterms, correct. So this is sum of minterm expression, and now what is difference between sum of minterms and sum of product? These are also product terms, and one student told me that product terms are the minterms. That is somehow correct. So there is some difference in between sum of minterms and sum of product. This expression we can also say that sum of product. We can say also sum of min terms. Okay. So one student was saying that these are the min terms. That is correct. But you should know what is the difference in product term and min term. Okay, I will give you one hint. Is anyone want to say something? Difference between product term and min term. This is a chance to clear your doubt from the first module. That's why I'm asking. If you will say something, I will correct you and you will learn that thing. Don't worry about that you are saying wrong.
So, sum of product can be any kind of sum of like 2 or 3 variables products. Like if we have like a plus b plus a dash plus c, anything, we will say that it is a sum of product. But in sum of min terms, we have exactly like one like x dash plus x dash 5 plus x y dash only kind of terms, min terms.
Yeah, so this is your sum. We told the difference between sum of product and sum of min term. So what is min term? You are in the right direction, Kusi. You try to say what is min term. So how product and min terms are differ?
Should contain all variables.
Yes, exactly what I was expecting. So difference is that in the product term and min term, let's consider we have 3 variables A, B, and C. Okay. So min term here in one side I am writing min term. Here I am writing product term. That we explained, we discussed in the first module. Okay. So min term can be A bar, B bar, C, and product term will be A bar, B. This A bar, B is not a product term, a min term. This is a product term, but it is not a min term. In min terms, each and every variable should involve. Like that, if you know, we have discussed problems in first module, convert SOP in the sum of min terms. So how we did? A bar B is the product term. How can we convert this in the min term? We can include C by taking C plus C bar complement. Then you will get A bar B C plus A bar B C bar. Now in this expression, you have all the variables in each term. So this one term is the min term, this one term is the min term. But A bar B is the product term, which is not a min term. Is this clear now? Picture about the min terms and product terms clear to you?
Yes, sir.
Okay. So here, 2 inputs are decoded into 4 outputs, D0, D1, D2, D3, and each output representing one of the min terms. Here we have only 2 inputs, A, B, so we will get 4 min terms. One is the A bar B bar, one is the A bar B, one is the A B bar, and one is the AB. Correct? So these are the 4 min terms. So each output is representing one min term. D0 is representing for A bar B bar, D1 is representing for A bar B, D2 is representing for AB bar, D3 is representing for AB. Is this clear? This logic
Yes.
diagram, 2:4 logic decoder. I will repeat once. In 2:4, we have 2 inputs, 4 outputs. At a time, only one output will be high. For each combination, your one output will be high. For 0, 0, D0 will be high, that is the min term 0. For 0, 1, D1 will be high, that is the min term 1. For 1, 0, D2 will be high, that is the min term 2. For 1, 1, D3 will be high, that is the min term 3. Okay, and expression will be D0 equal to A bar B bar, D1 is A bar B, D2 is AB bar, and D3 is AB. And if we design the logic circuit diagram for this, that is the here given here. I think I don't need to explain this thing. This is simple task. You can understand easily with the given expression. Now we move to the decoder with enable input. Decoder with enable input. Why we required enable input? That we will talk about here. Decoder will work only when enable input is high. Just consider we have some device at our home. Not generally I'm talking about the decoder, any device. That device will enable only when you switch on the device. This enable is nothing but a switch. Okay, when this switch will be on, it means E is equal to 1. In such case, your decoder will work. For the given input combination, your output will be high only when enable input is high. Okay, if E is equal to 0, it means enable input is disabled. This input is disabled, switch is off. In such case, output of decoder will be 0. All the outputs, not only one, all the outputs of decoder will be 0. And any one output will be high when enable input is 1. So here, this is the diagram for 3:8 decoder. As you know, decoder is n into 2 n. So 3:8 decoder. 3 inputs, 8 outputs. So D0 is combination as A bar, B bar, C bar. But this expression is correct when enable input is not given. How can we include the enable input? And enable input we need to multiply with E. Then this output will be high when A, B, and C are 0, but enable input should be on. Enable input should be 1. Okay, so D0 is A bar, B bar, C bar, E. D1 is A bar, B bar, C, E. D2 is A bar, B, C bar, E. D3 is A bar, B, C, E, and so on. D7 is A, B, C, E. All you can see in the right side, all the E are 1. That's why complemented is not used here. And these expression will be high only when E, at least E should be high. If E is 0, that means all the outputs are 0. If E is 1, then only one output will be high based on the input combination. Okay? Is it clear?
Yes.
And here you can write this is 0 minterm, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7. Now, what is the use of decoder? Why are we learning here? Point is that we discuss about 2:4 decoder. We discuss about decoder with enable input using in 3:8 decoder. In 3:8 decoder. But why are we learning? What is the use in the Boolean algebra, in the digital logic design? That we'll see here. Implementation of any expression with the help of decoder is possible. Implementation of any expression is possible using decoder. So before discussion about the full adder implementation, I will just discuss you one expression, simple expression. Implement XNOR gate using decoder. Okay, 2 input XNOR gate. Here I mentioned 2 input XNOR gate. So first you tell me, before implementing this, you should know what is the expression for XNOR. Here we have given 2 inputs. Let's we consider input is A and B, and output is Y. Okay, output is Y. Inputs are A and B. So what will be the expression for output? Y is equal to an XNOR gate. What is the expression of XNOR gate? Do you remember?
A dash B plus B dash A.
A dash B plus B dash A. Is this correct?
AB plus A bar B bar.
AB plus A bar B bar. Which one is correct, audience? Okay, this is equation 1, this is equation 2. Now, students, you write 1 if according to you 1 is correct, write 2 if 2 is correct in the chat box. Two expressions I have written for XNOR gate. Write 1 if expression 1 is correct for XNOR. Write 2 if expression 2 is correct in the XNOR. This is a simple logical expression of logic. This is a simple expression for logic gate that you should know, everyone. Only I got 2 outputs, 2 results, 3. Just I want to see how many of you active right at this time. How many of you are listening me? If you are listening me, write 1 or 2. It doesn't matter you are writing correct or wrong. Okay. "63 are present. I at least I expect 50 students will reply to me if you are listening me. Either write either 1 or 2. Write 2 if 2 is correct. Write 1 if 1 is correct. Okay. Okay, so everyone agree statement 2 is correct. So here expression for XNOR gate is AB plus A bar B bar. Okay, so now I will draw the 2 is, so first of all you tell me what kind of a decoder is required. I mean what size decoder is required here? What size decoder is required?
2 into 4.
2 into 4 because 2 inputs are here. We have 4 minterms. So we will use 2:4 decoder. Okay. Now I'm going to draw one decoder circuit. Two is to 4 decoder. Okay. Inputs are A and B. Minterms are here. You can write A bar, B bar. You can write anything. A bar, B bar, Y0, Y1, Y2, Y3. But in such case, if you are writing Y0, Y1, Y2, Y3, you should mention Y0 equal to A bar, B bar, Y1 is equal to A bar, B, Y2 equal to AB bar, or Y3 equal to AB. Okay. Or you can write here 0, 1, 2, 3 also. A bar, B, AB bar, and AB. Okay. So what is the expression? AB plus A bar, B bar. So in such case, we have these output A bar, B bar, A bar, B, AB bar, AB. Now we need to use AB and A bar, B bar. One is this A bar, B bar, one is this AB. And we'll give these output of the decoder to the one OR gate, and you will get the expression for XNOR gate. So in this way, we can design any logical expression, not only logic gate. We can design any logical expression, AB plus A bar B bar. But thing is that you will have to represent sum of product expression to the sum of minterms, because here you know what is the minterm. Here we have given minterm. Are you getting me? Here we have given minterms, so you will have to represent each expression in sum of minterms that we have seen in the first module. Now, come to this problem, implementation of full adder using decoder. Implementation of full adder using decoder. So this is as XYZ, summation of M, 1, 2, 4, 7. What are these 1, 2, 4, 7? Do you know? What is this expression? In the very beginning, I told you first module is very important. Each and everything will be used in the second and third module.
Positions in K-map.
Okay, position in K-map. So what is this expression? Here we are not talking about the K-map. What is this expression? Sigma M 1247. What does it mean?
Sum of minterms.
Sum of minterms. Or already written here in sum of minterms we have given. Okay. How did we get here? How did we get this expression is sum of minterm for sum in full adder, and how we got this expression is carry in the full adder? How did we get? Let's see. How can we get this expression of sum and carry? You know, in full adder, we have 3 inputs. Let's consider X, Y, Z, because I think X, Y, Z is considered here input. X, Y, Z are our inputs, and sum and carry is our output. Okay. We create truth table 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay. Now you know what are these things. Now you know what are these things. This is minterm 0, minterms. I'm writing here minterms. 0, 1, 2, 3, 4, 5, 6, and 7. Okay. Now we'll check according to this inputs xy, according to these inputs xyz, what will be the value of s and c. For 0, 0, 0, sum is 0, carry is 0. For this expression, you tell me 0 plus 1.
Sum
Sum
1
is
carry 0.
okay. For next 0, 1, 0. Yeah,
Sum
tell
1
us.
carry 0.
0, 1, 1.
Sum 0 carry 1.
Sum 0 carry 1.
Carry 1.
1, 0, 0.
Sum 1 carry
Sum
0.
1 carry
1
0.
carry 0.
1, 0, 1.
Sum 0 carry 1.
0 carry 1.
1, 1, 0.
Sum 0 carry 1.
1, 1, 1.
Sum 1 carry 1.
Sum 1 carry 1.
Excellent. Good. So now here we got this truth table. From this truth table, you can write the expression. Sum inputs are x, y, z. This is nothing but equal to summation of minterms. What minterms are high? 1, 2, 4, and 7. That this also we have seen in the module first. Similarly, you can write the expression for carry. You tell me what can we write here? C x, y, z is equal to summation of m. Tell me
3, 5, 6, 7.
3, 5, 6, and 7. Okay. So these two expressions we got in minterms, in sum of minterms. Now what can we do? We'll have to design decoder. Sum is summation of m 1, 2, 4, 7, and carry is sum of m 3, 5, 6, 7 that we got here. You can see 1, 2, 4, 7 and 3, 5, 6, 7 that we got from the truth table of the full adder. Now, what size decoder we require? Now we'll use decoder. What size decoder we required in full adder?
3 into 8.
3 into 8.
3 into 8 decoder we required because you can see we have 3 inputs x, y, z. Okay, so 3 into 8 decoder we will use to design full adder. Inputs are x, y, and z. Outputs are minterm 1, minterm 0, minterm 1, 2, 3, 4, 5, 6, and 7. These are the possible minterms that we have. Let's see, I write here 0, 1, 2, 3, 4, 5, 6, and 7. Correct? Now, some expression is sum of 1, 2, 4, 7. So you take 1 from here, you take 2 from here, 4 from here, and 7 from here. Give all these inputs, all these outputs of decoder as an input to the OR gate. This is sum. Okay. Similarly, we can design the carry output with the help of 3, 5, 6, 7. So this is the 7, this one is a 6, this one is 5, and this one is 3. Okay, and all these inputs, all these are the input to the OR gate or carry. So in this way, you can design any expression, but you need to write the expression in sum of minterms. Is this picture clear to everyone? So this is the circuit diagram. Here you can see this is the implementation of full adder using a decoder. Here we have 1, 2, 4, and 7 are the input for the OR gate of the sum expression, and 3, 5, 6, 7 are the decoder output as an input to the OR gate for carry expression. Similarly, you can implement half adder, half subtractor, and full subtractor using decoder. And this is the task that you will have to do. You have already truth tables for half adder, you have already truth tables for subtractor, and half subtractor and full subtractor. So you can easily design, you can easily implement adders and subtractor with the help of decoder. Do you have any query so far? Would you like to ask anything? Okay, now another survey is that if this topic is clear to you, you got some idea, write Y, otherwise write N. In the meeting chat, you write Y or N. If this is clear to everyone, write Y. I want to see how many of you are attentive here. If you got some idea how to design expression with the help of decoder, what is decoder, what is 2:8 decoder, what is 3:8 decoder, you write Y. Otherwise, you can write N also here if you didn't get. What is the meaning of T here, Asutosh? In between Y and N. Okay, it means many of you are listening to me and you are getting the things what is decoder. Okay, so now what we will do, we'll implement some higher order decoder with the help of a lower order decoder. Like that here, this is the one presentation. Okay, so in this topic, I mean implementation of 3:8 decoder using 2:4 decoder. We'll see how we can design 3:8 decoder with the help of 2:4 decoder. Okay, so right side you can see one diagram is given, and this one is a 1:2:4 decoder. This one is a second 2:4 decoder. Now you can understand the concept of enable input. Now you can understand the concept of enable input. And these 2:4 decoder are with enable input. This input is most significant bit A, which is MSB of 3 input in 3:8 decoder. This A is the MSB, most significant bit. This C is the least significant bit. Okay. So now what happened? What you can see in figure, A is the most significant bit, C is the least significant bit. When A is 0, just consider when A is 0, in such case, you tell me which decoder will enable. When A is 0, which decoder will enable? Decoder 1 or decoder 2?
Decoder 1.
Yeah, if input is 0, this will be 1, and here you can see this input 0 is going to the enable input in the decoder 2, and here 1 is going in the enable input in the decoder 1 because inverter is connected here. Okay, so this one is enabled. Now all these 4 outputs are 0 because this decoder is disabled. It is not enabled. Now you will get the output from only first decoder, and you will get the output if 0, 0 input, this D0 will be high. If input is 0, 1, D1 will be high. Input is 1, 0, D2 will be high. Inputs are 1, 1, D3 will be high. Okay, so 0, A0, BCR 0, 0, D0, 0, 0, 1, D1, 0, 1, 0, D2, 0, 1, 1, D3. Now come to the most significant bit again. Now come to the most significant bit again. If A is 1, which one disable, which one enable?
Second one is
Second one.
enabled.
Second one will enable. and first one will disable, and all the outputs of first decoder will be 0. So now you have 4 combinations: 1 0 0, 1 0 1, 1 1 0, 1 1 1. Okay. Now here B and C are these two inputs. This is B, this is C. Based on the combination of the input B, C, like that 0 0, this D5 will enable, or D4 will enable. For 0 1, this D6 will enable. For 1 0, for 0 1, D5 will enable. For 1 0, output D6 will high. For 1 1, output D7 will high. Are you getting some rough idea? Something you are getting how we are generating 3:8 decoder with the help of 2:4 decoder?
Yes, sir.
I'll
Yes.
explain in more detail. Don't worry if you are not getting, I will explain it again. Just I'm giving you rough idea how we can design. So concept is that we need to use one inverter between 2 decoder for enable input, and at a time only one decoder will high, and based on the input combination of B and C, your output will high. This is the concept. When A0 top decoder is enabled, other one is disabled. From top decoder or first decoder, output generates from 0 to 0 1 1. That is D0 to D3. When A is equal to 1, second decoder will enable and top one is disabled. From bottom decoder, output generates from 1 0 0 to 1 1 1. That is D4, D5, D6, and D7. Similarly, you can construct 4 into 16 decoder with the help of 2 3:8 decoder. Now I will explain here once again for better clarity about this. 3:8 decoder using 2:4 decoders. Okay. Now here I'm drawing one truth table. I'm constructing one truth table here. For this, inputs are A, B, C. Output is Y. Just consider Y. Combinations are 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 1. Okay. Now draw one line between here, and output will be D0, D1, D2, D3, D4, D5, D6, and D7. Okay. So one decoder we required for these first 4 combinations. One decoder we required for the next 4 combinations. 1 2:4, another 2:4. Obviously, here we will get 2 input, 4 output. Similarly, here we will be having 2 inputs and 4 output. Outputs are D0, D1, D2, D3, D4, D5, D6, and D7. Okay. And we will use one enable input here with one NOT gate. We can connect here. Okay, this is the input A, this is the input B and C. Okay, this is also B and C. So now you can think, if input A is 0, input A is 0 is these 4 combinations. If input B and C are 0 0, output D0 will high. Input 0 1 is B and C are 0 1, D1 will high. Input B C are 1 0, output D2 will high. And inputs 1 1, input B and C are 1 1, output D3 will high. But it depends on enable input. This is the enable input. Enable input should be 1. Here, if A is 0, this enable input will become 1 and this enable input will become 0. So in such case, this decoder will disable. Now if I give input A is 1, in such case, bottom decoder will work and this E equal to 1 and here this E will be 0. So this will not work and based on the 0, 0, 0, 1, 1, 0, 1, 1, your D4, D5, D6 and D7 will enable. But at a time, in one combination, only one output will be high. Is that okay?
Yes.
Is this concept clear?
Yes, sir.
Okay. Similarly, you can construct 4 into 16 decoder with the help of 2 3:8 decoder. In such case, what you have to take? You can write 3:8 decoder and fourth, that is the most significant most significant bit input will work as a enable input. Okay. Similarly, you can do here instead of 2:4, you can take 3 input, 8 outputs both sides. Most significant input will work as a enable input, and you can easily design. Can you do that? Simple task. 3 into 8. This is 3:8. This is also 3:8. D0 to D7 output will be in this first decoder. D8 to D15 output will be the second decoder. And 3 inputs here, 3 inputs will be here, and 1 input, that is the enable input, most significant input, will work as an enable input. That is a simple task. If you understand this one, you can easily do that 4 into 16 decoder with the help of 3 into 8 decoder. Okay, so this part I will explain you tomorrow in the next class. Before that, just we'll see one more expression, one more example. If function xyz is here, design x bar y z bar plus xyz plus x yz bar plus x bar y bar z bar. This is the expression we have. We want to implement using decoder. If I ask to you, implement this given expression using decoder. Just implement this expression using decoder. Now you will have to tell, I will draw here. You tell me what is the procedure. How can we do that? What is the first step? You can unmute yourself and you can tell me. What is the first step? How can we design decoder with the help? How can we design this expression with the help of decoder? How can we design? Okay, first question is that what is necessary to design the decoder in the expression? To tell me, is this expression in proper format that we require? Reply me in yes or no. Because you will learn when you will interact more. You will learn more when you will interact more. Okay, no problem. I will explain. So what first thing we require for expression should be in sum of minterms. First mandatory thing, sum of minterms. Minterms means in each term all the variables should present. Here you can see that f, x, y, z. 3 variables, all are present in each terms. So you can directly now you can design 3:8 decoder with input x, y, and z. Inputs are 1, 2, 3, 4, 5, 6, 7, and 8. Okay. So this is 0, this is 1, this is 2, this is 3, 4, 5, 6, 7. Can you write this expression in sum of minterms? Can you write? You tell me. What is X bar, Y, Z bar? In terms of number, in min terms, what is X bar, Y, Z bar? 2. It is 0, 1, 0. So it will be 2. Okay. What is X, Y, Z?
7.
What is X, Y, Z bar? 6. What is X bar, Y bar, Z bar?
0.
0. So what we required, 1 is 0. We can take 1 is 2, 1 is 6, 1 is 7, and give all these output of the decoder in the OR gate, because all these terms are in the addition. All these terms are in the addition. You can get this expression by this function. Okay. I hope it is clear to everyone. This is X bar, Y bar, Z bar. This is X bar, Y, Z bar. This one is X, Y, Z bar, and this one is X, Y, Z. All those terms we have taken and just we are giving to the OR gate, you will get the expression fxy, because these are the min terms that we are adding here to get the functions that is given in the question. Is it okay? So today I will stop here. In the next class, we will discuss some more about the decoder. Thereafter, we will discuss about the encoder. If you have any doubt, any query in the decoder part, you can ask the questions. Do you require this PDF file? Because I have written in the little rough manner. Do you require? If you require, I will save. Otherwise, I will not save this file. Will this PDF file will helpful to you?
Yes, sir.
Okay, I will save this for you, and I will share this presentation also. Both file I will share with you. Okay. So now I'm going to unshare my file, unshare my screen, and yeah. I'm just downloading your attendance. You can leave if you don't have any query. You can leave now.